In example 8, we're going to be changing to base e. So if we're given a model with the form of y is equal to a times b to the power of x, and we're going to change it to the form y is equal to the initial value e to the kx, we're first going to rewrite y is equal to a times b to the x as y is equal to a e to the power of the natural log of b to the power of x. And then we're going to use the power rule of logarithms to rewrite that function so that we can say that a e to the x times the natural log of b is going to equal to a times e to the natural log of b times x. And let's make note that a is the initial value and k is going to be the natural log of b in that equation. So change the function of y is equal to 2.5 times 3.1 to the x so that this same function is written in this form. So let's identify what represents a in this function. Well, we know that a is 2.5 and we know that b is 3.1. And then we're going to insert an exponential and its inverse. So now we're going to use this formula, and then we're going to plug in a to be 2.5, and we know that b is 3.1. So now we have y, which is equal to 2.5 times e to the natural log of 3.1 to the x. And now in our exponent, we can then use the power rule to write the x in the front. So now we have y, which is equal to 2.5 e to the x times the natural log of 3.1. And then we're just going to use the commutative law of multiplication to write the x at the end of the exponent. So then we end up getting y, which is equal to 2.5 times e to the natural log of 3.1 x.